So we did a little bit of this in the project that we did on Friday, and so we're talking about composition of rigid motion. And that's when you take a transformation and you do two in a row, okay? And your final, transformation is rigid motion, all right? So you might reflect and then rotate, or you might translate and then rotate, or rotate and then reflect, okay? And so if it tells you what to do in words, then you do it according to how it tells you to do it. But there is a notation where they use an open circle, okay? And if they use that open circle, that indicates composition, and you do it backwards. You do the second thing first, and then the first thing. So in this problem, this is a reflection over line L composed with a translation of the vector -2, 5. So I'm going to take my pre-image and I'm going to translate it through the vector -2, 5, and then I'm going to reflect it over line L. Right? You do it backwards when it has the open circle. But if it just says it in words, then you do it how it tells you to say it, okay, or to do it. Alright, so here is one where it uses the open circle, the composition notation. It wants us to reflect over the x-axis composed with a translation through the vector 3, -1. And it's just a line segment A. So what do we do first? The translation or the reflection? No, what did I say you do first? The second thing you do first, when it has that open circle. So you're going to do the translation, and then you're going to do the reflection, right? And you can do it all in the graph, or you can use the rules. It doesn't matter. On the rotations, I would probably definitely use the rule. That's a little hard to do on the graph, okay? So we can talk about it both ways. All right, so let's say I did on the graph, all right? So I'm going to translate to the vector 3, -1. So that means that I'm going to take each point, and I'm going to go 3 units to the right and 1 unit down. So 1, 2, 3 down. That's going to be my new A. And my B is 1, 2, 3 down. Okay? So that's what I get after the translation. Okay? And then I'm going to take those new points, and I'm going to reflect it over the x-axis. Here's the x-axis. So then I take my new point A, and since I'm 2 units below, I'm going to reflect, and I'm going to go 2 units above. And my B is 2 units above, so when I reflect, it's now 2 units below. Okay? And so that is my primes, my A prime, B prime, because that's the final position, that's my final image for the composition of a reflection of the x-axis composed of the translation of vector 3, -1. Okay? Now, I could have used the points. Okay? My A was at -2, 1, and my B was at 1, 3. So if I do the vector 3, -1, that means I add 3 to the x and subtract 1 from the y. So then my new A would have been 1, -2, and my new B would have been 4, 2. Okay? Then I need to do a reflection over the x-axis. What's the rule for reflecting over the x-axis? You remember? Right. We did it by graphing, but what's the rule? You remember what the rule is? You change the opposite coordinate. So if I reflect over the x-axis, I change the sign of the y. That's it. Okay? So that would be x -y. So then I take these new points, and my x stays the same, and my y changes signs. And I take my new B points, and my x stays the same, and my y changes signs. And so if I come over here and look, my A prime is at 1, 2, and my B prime is at 4, -2. So, again, you can do it with graphing, or you can do it by the rules. Sometimes you gotta do a little of both, okay? Okay, here's one. So this is one in which they use the composition notation. The next one that we're going to do is going to tell us what we do in words. Did you get that? Okay. All right. So here it says triangle JKL. JKL has the following vertices, which I've graphed for you already. You want to graph it and its image after a translation along the vector 0, 4 and a reflection in the y-axis. Okay? So again, you can use the rules, or you can graph it. Okay? So if I translate over the vector 0, 4, or through the vector 0, 4, what does that mean I'm going to do? And you're going to do this one in the order because it's not in the notation. So what does a translation through the vector 0, 4 mean I'm going to do? I'm going to move which way? Up, down, left, right, both? What?
Up 4.
Up 4, right? Because the first number tells you don't go anywhere left or right. Second number says you go up 4. Now, be careful. These are by 2s, okay? So when you count, you got to be careful. Okay, so I'm going to go up 4. 1, 2, 3, 4. There's going to be my J. Up 1, 2, 3, 4. There's the L. And K. Up 1, 2, 3, 4. Okay, so there's the translation. Okay, then we're going to reflect in the y-axis. This is the y-axis. Okay, what's the rule for the y-axis? The x-axis, you switch to y, so if you reflect over the y-axis, you change the x, right? Okay. So, here I am 5 to the right, so I'm going to go 5 to the left. That is my L prime. J is 6 to the right, so when it reflects, it's going to go 6 to the left. And K is 10 to the right, so when it reflects, it's going to come over here and go 10 to the left. So I went up, and then I reflected over the y-axis. Alright. And again, you could have used it with the rule, that's fine. If you like to do graphing, that's fine too. You definitely need the original pre-image and the final image, okay, when you graph. Right. Because the y doesn't change, it's the x changes places. Okay, has everybody got that? Okay, one more that we'll do, and then I'm just going to talk to you about something on that side. The endpoints of CD are C, which is at -7, 1, and D, which is at -3, 2. Let's go ahead and graph this. So -7, 1 is my CD, and my D is at -3, 2. Okay? It says graph CD and its image after a reflection in the x-axis and a rotation 90 degrees about the origin. Okay, so which one are we going to do first? If it says it in words, you have to do it exactly the way it says it. So you're going to reflect in the x-axis and rotate 90. If I were to write it in composition notation, then I would do rotate 90 about the origin, compose with a reflection in the x-axis. Okay, that's how it would be written, but when it's in words, you do it the way it tells you to. Okay, so I'm going to do the x-axis first, and let's do the rules this time. Okay, what's the rule for reflecting over the x-axis? You change the y, so it's x negative y, and then you rotate 90 degrees. What's that? So what happens when you rotate 90 degrees?
Flips signs.
You change the sign of the y and they switch places. Okay? Alright, so this will become -7, -1, and D becomes -3, -2. That's the reflection, right? Then we take those 2 points and we rotate them 90 degrees, which means you change the y and then switch. What does that become? 1, -7, and you change the y, which is 2, -3. Okay? So this is going to be my C prime and my D prime. So if I graph that, we're at 1, -7. There's C prime. And then D prime is at 2, -4. And didn't graph the one in the middle. You could if you wanted to, but you don't necessarily have to, unless you're doing everything by graphing. Okay? Any questions on what I did? When it gives it to you in words, you do it how they tell you to. This is what it would look like if it was in a composition notation. Since we're doing the x-axis first, that's what comes second, right? It's come backwards, but that's how it works. Okay? All right. So the last thing I want to show you, we're not going to work any of these, but some special situations that happen is, let's say you have two parallel lines, okay? And if you reflect over one of the parallel lines, and then you reflect again, you actually get a translation. See? If I take this arrow and I flip it over one parallel line, and I flip it over another parallel line, I actually get a translation. And it's always 2 times the length, the distance between the parallel lines. Okay? If I have intersecting lines, okay, see how I've got P and Q that intersect at a 75-degree angle? If I do 2 reflections over intersecting lines, you actually get a rotation. Okay? So, and it's always twice the Alright? So we're not going to have any of those, but I just want to point that out to you.